The blinking or flashing clean light is a fault detection within the software of the dishwasher control. This is the control's way of telling you that something is wrong. Do not replace the control before checking all of the possible causes we will discuss in this video.
Warning: electrical shock hazard. Disconnect power before servicing. Replace all parts and panels before operating. Failure to do so can result in death or electrical shock.
Here's how this fault detection works. The thermistor, located beneath the accumulator inside the sump, detects the temperature of the water as it begins the first 8 minutes of the main wash cycle. During this time, the control will expect the thermistor to detect a 2 to 4 degree rise in the water temperature when these first 8 minutes of heated wash are complete. If the expected temperature rise in the water is not met, the control will not be satisfied. It will then shut the dishwasher down and blink the clean light 7 times. The consumer will not be able to restart the dishwasher using conventional programming commands and must call for service to have the product diagnosed. As we demonstrate how this works, we will simulate 130 degree water entering the tank. As the first cycle begins, this water is circulated throughout the dishwasher, coming in contact with the cool tank and dishes. It is after this circulation takes place that the thermistor detects the temperature of this water and communicates this to the control. In this case, the water has cooled down to approximately 110 degrees. The product then continues through the first 8 minutes of the main wash cycle. During this cycle, the heater element comes on and the pump and motor assembly begins to circulate the water. As the water circulates throughout the dishwasher, it passes over the heater element, which increases the temperature of this water. Once the cycle is complete, the thermistor detects the ending temperature of the water. The control checks to verify that the water temperature has increased a minimum of 2 to 4 degrees. In this case, our beginning wash water temperature was 110 degrees, so the thermistor must sense a temperature greater than 112 to be satisfied. If it does, the dishwasher will continue on to the next cycle. If it does not, the control will shut the product down and blink the clean light 7 times. Here is one very important item to note. If, at the beginning of the main wash cycle, the thermistor detects extreme temperatures, colder than 62 degrees or hotter than 160 degrees, it will bypass this fault detection and not check for a 2 or 4 degree temperature rise, but rather it will just continue on to the next cycle. For this reason, extreme water temperatures, either too cold or too hot, cannot cause the blinking clean light failure. Telling a consumer to either turn their water temperature up or down is an incorrect diagnosis of the real failure. Understanding this, an open or failed thermistor cannot be the cause of the failure either, because when a thermistor fails, it sends an extreme temperature reading to the control, which would cause this fault detection to get bypassed. Let's watch our demonstration of the first 8 minutes of the main wash cycle. One more time. The heater element must be energizing. There must be water in the tank. The water must be passing over the heater element. These are the 3 areas of focus when diagnosing the blinking clean light. If the heating element is not energizing, it will not be able to heat the water the 2 to 4 degrees necessary to satisfy the control. Make sure there is continuity within the heater element circuit. This can be verified by checking the operation of the heating element using the diagnostic cycle illustrated on the text sheet. Check all electrical connections within the heater circuit to make sure they are tight and secure. This includes the connections at the heater, thermostat, control, and door switch. Check to make sure the heating element component itself is good. It should read 10 to 35 ohms resistance. Check the high limit thermostat to make sure it is not opened and that all the connections are tight. Last, but certainly not least, make sure the door is closing and latching properly. Here is why this is very important. The heater element circuit is in line with the neutral door switch. It is possible for the door to be closed, making the connection to the L1 switch, but not the neutral switch. If this were to happen, the unit would run until it got to the end of the first wash cycle and then shut down because the heater element never came on to heat the water. The installation of the plastic tub dishwasher heavily impacts this door switch failure. In order for the strike plate to come into direct contact with both the neutral switch and the L1 switch, the dishwasher must be level and secured to the cabinet. If the dishwasher is wedged crooked into the cabinet or not level, there will be an imbalance in the strike plate and the door switch, increasing the likelihood of this failure. If the dishwasher is not secured to the cabinet, It creates variation in the door closure forces, again making it more likely for one side of this switch to make connection while the other does not. Be sure to check that the door switches are both secured in place and their mounting screws are fully seated. Also check the mechanical operation of the latch bolt for binding. As we discussed, the thermistor will detect the temperature at the beginning and end of the first 8 minutes of the main wash cycle. If there is not enough water available to heat efficiently during this portion of the cycle, the thermistor will not detect the 2 to 4 degree heat rise necessary to satisfy the control. Begin by making sure the water to the dishwasher is turned on. This is especially important for new installs. If there's water coming in, be sure to check for siphoning. Make sure the float is not stuck in the up or full position. Make sure all of the connections to the water valve and float are secure. If there is still little or no water entering the machine, be sure to check the water valve component itself. As shown in our demonstration, the water must pass over the heater element in order to heat up. If it does not, the temperature of the water will not rise the 2 to 4 degrees necessary to satisfy the control. Make certain that the pump and motor are working properly. Check all of the connections that could impact the operation of the pump and motor, including the wires of the motor start capacitor. Be sure to check the chopper assembly for anything that may be restricting the water flow through the pump and motor assembly, keeping the water from circulating over the heater element. If you have checked all of these things that could cause the water to not heat up during the wash cycle, and you are still unable to determine the problem, please contact your technical support for additional help. Once you have determined the root cause of this failure and have corrected the problem, please be sure to code the call correctly and enter detailed comments of how you resolved this failure. These comments are important in our efforts to make future improvements that will limit these failures. Before leaving the home, be sure to clear the failure code by entering the diagnostic mode. For the new diagnostics, do this by pressing heated dry, normal, heated dry, normal. One improvement we have incorporated into future models involves a software change in the second generation control board that requires the temperature rise check to fail in 3 consecutive wash cycles before shutting down the dishwasher and flashing the clean light. This second generation software was developed to reduce nuisance tripping of the clean light. We have also made some changes to the second generation control hardware to improve the integrity of the control. To clearly understand these changes, let's review a strip circuit that illustrates the components and circuitry of the first generation control. In the heating circuit, power flows from L1 through the thermal fuse, the L1 door switch, the K2 relay located on the control board, the high limit thermostat, the heating element, and the neutral door switch to complete the circuit. Next, let's review the strip circuit illustrating components and circuitry of the second generation control. In the heating circuit, power flows from L1 through a non-resettable bimetal, the L1 door switch, the K2 relay located on the control board, the high limit thermostat, the heating element, a new K3 heater relay located on the board, and the neutral door switch to complete the circuit. The non-resettable bimetal on the second generation control replaces the thermal fuse used previously on the first generation controls. On second generation models, the neutral door switch will be found only on plastic tub dishwashers as per UL requirements. It is very important to note that these controls are not interchangeable. The diagnostic and servicing procedures for first and second generation models are similar. Refer to the specified text sheet of the unit being serviced for further information. This concludes our video on the blinking or flashing clean light fault detection.